Hey guys, Will here. Welcome back to the channel. Now today's video I'm going to be showing you the basic settings that I use to overclock an 8700K or 8086K processor. So if you've been watching my previous videos, you would know by now that effectively they're the same chip as each other. The 8086K just in most cases overclocks slightly better than the 8700K with slightly lower VCORE voltages. So we're going to be using the Maximus X motherboard in this video, so the ASUS Maximus X. I'm using the code, but the settings are basically the same for all of the Maximus X motherboards, and a lot of these principles can be applied to most motherboards. I am working on another video series that's going to go through all the various different settings, what they actually mean in order to fine-tune your overclock and actually teach you guys how to overclock as a principle and what all the different settings mean, that kind of thing. The purpose of this video is more just to give you a top-level overview of the settings that I used out of the box to achieve the results that I've been able to achieve, because I do get asked that a lot. Now, I kind of was reluctant to do this video because I think it's important to understand the principles, but in saying that, I do get a lot of questions from people just wanting to know what settings I used, so I thought I'll make the video, but I do want you guys to watch that video later on that I make about the, the principles of overclocking, because that will give you a much better understanding of how all of this stuff actually works behind the scenes, and give you the ability to really fine-tune and dial in the settings that you'll use for your final overclock on your particular system. Because of course, every motherboard's a little bit different, every power supply is a little bit different, every stick of RAM's a little bit different, every graphics card is different, and of course every CPU is different as well. So the settings that work for me aren't necessarily going to work exactly the same for you guys. In fact, I'd be extremely surprised if the settings that I use work exactly the same for your system. But what we're going to do here is run you through basically the settings that you can use to get a good base point and then fine tune from there. Okay, so let's jump into it here. Now, the first thing you'll notice here is that I'm using the BIOS to overclock the processor, not the Windows tool, the AI suite. I have a lot of problems with AI suite. I find that it introduces a lot of other instabilities. I get a lot of blue screens just from the software itself, and I find it glitchy and buggy. And also, if the system hangs, you can get yourself in a situation where your fans don't speed up properly, things like that. So it's much better to have all of this controlled at a BIOS level or at a basic system level rather than using the AI suite. So I'd encourage you not to play around with AI suite. That can be useful for fine tuning sometimes because it lets you test different voltages without having to reboot all the time. But everything that we're going to be doing in this video is going to be done from within the BIOS. So to get into the BIOS, you press F2 right at the very start of booting up your PC. So hit your power button, press F2 a bunch of times when it tells you to do so, to enter setup, and that will take you to the screen that you see in front of you right now. So in most cases, you'll be taken to the extreme tweaker screen straight away. Moving straight from the beginning, we've got a My Favorites, which is the settings that you use most often. You've got your main profile here, and then you've got your extreme tweaker screen, which is where we're going to be doing the majority of the stuff that we're doing here. Now, it is also important if you've just built a new system to set up all your fan profiles correctly too. And I usually like to set up all my fan profiles and then save my BIOS settings from there, then go in and do my overclocking later, because it means if I have a problem and I have to reset my BIOS, I can always revert back and get those fan settings back without having to start completely from scratch. And I will be doing another video about thermals and how to set up your fans properly so that you get maximum cooling efficiency with minimal noise. So jumping into the actual overclocking settings here, we go down on our extreme tweaker screen. We can see AI Overclocking Tuner here. So actually before that, we'll look at Overclocking Presets. So in here, you've got a bunch of presets here which are good for various different overclocking levels. You can see there's a 5 gigahertz here, a 340B clock overclocking profile. Now, I stay away from these. I avoid these with a 40-foot pole because they tend to push your voltages much higher than what is safe. Particularly if you're running an air cooler, I would definitely recommend not touching any of the presets that come out of the box, especially with ASUS motherboards, because they seem to push the voltages to just ridiculous and dangerous levels. Now, in saying that, in most cases, the thermal protection will kick in before you actually cause any damage to your system, but it's not good to be running those high voltages for long periods of time, as we will explain in later videos where we talk about voltages and stuff like that. But moving down here, you've got your AI Overclocked Tuner. The first setting I've got here is manual. Now, you can use the XMP profile, which is the extreme memory profile, and obviously we'll be explaining that in more detail in later videos as well. But I always set this to manual and actually tune my RAM to the settings that it comes with manually. But you can use XMP here if you want to. It just makes things a little bit easier. Jumping down to B clock frequency, I usually leave this at the factory setting at 100 megahertz, because raising the B clock frequency actually raises the frequency in which the motherboard communicates with a few different components within the system. It's not as bad as it used to be, where it doesn't overclock your hard drive and stuff like that anymore, but it can introduce instability at a clock speed that would otherwise be stable. So as a starting point, I like to leave this at 100. We can fine tune it later on. Now, ASUS multi-core enhancement. This is used to adjust how the CPU ratios work out of the box. So the CPU out of the box using the factory Intel settings will always reduce the clock frequency depending on how many cores of the processor are active and under load. Now, what happens is in the majority of cases, most software is going to use all cores anyway, so you'll find that your frequency will actually drop as you introduce load into the systems. So ASUS multi-core enhancement actually adjusts those settings and raises the core frequency across all cores. But what we want to do here is leave that disabled, because we're going to set this up ourselves using our own manual settings. So leave that disabled. SVID behavior, there's a bunch of options here. Normally it will be set to auto. I've got it set to typical scenario, but with the settings that we're going to use in this video, this doesn't actually matter because we're not going to be using SVID to control the voltage. So SVID basically refers to a table that's programmed within each individual CPU that tells it, okay, at this clock frequency, I'm going to need this voltage to run at a stable setting. So using these different settings here, best case scenario would mean that it's going to run lower voltages. Typical scenario would be, an average case, and then worst case is obviously worst case scenario. But doesn't really matter what we're going to set this to, because we're going to use a manual override on our clock on our VCORE anyway. So leave that as it is. Avx Negative Offsets. So what this is the Avx offset basically lets the CPU clock down under AVX load. Now, AVX load is a relatively new thing, and AVX instructions for a CPU are a lot more intensive. They require a lot more power to run stable, and they generate a lot more heat as well. So when you've actually finalized your overclock, often in cases you can find that you'll reach a higher clock frequency under non-AVX instruction scenarios. So what you can do there is actually put in an offset here, so that when you're running non-AVX, your CPU clocks up a little bit further, and then when you're under non-AVX load, you can actually ring down that clock frequency a little bit more. So as you can see, my current overclock, I've got this set to 1. If you're starting straight out of the box, I'd recommend setting this to 0 and setting a lower beginning clock speed. I know DeBauer's video where he went through a similar scenario, he set this to 2 or 3, I think it was, but that really doesn't give you a good base point to establish stability. So I like to set this to 0 to begin with, and then we move down to our core ratio. So as we mentioned before, out of the box, the core frequency will adjust depending on the amount of load. We want to set this to sync all cores, so that all of our cores will be running at exactly the same frequency all of the time. So we move down now to our core ratio limit, and as you can see here, when we adjust this, all the cores adjust because we're syncing all the cores together. So I have this set to 52 for my particular processor. What I would recommend here is, if you're just starting straight out of the box, if you've got an 8700K, I would set this to 48. If you've got an 8086K, you can probably get away with setting it to 50 straight out of the box. Air cooler, you might be pushing the limits here. Water cooling, definitely, I think you'd be okay. So moving down now to our DRAM frequency ratio, I always leave this set to automatic. Won't go into the details of this now because it's kind of beyond the scope of this video. DRAM odd ratio, leave that to enabled. DRAM frequency, so obviously this is going to be set to match the frequency of the RAM that you've purchased. So you'll need to look at the packet of your RAM, or just use the XMP profile here to set up the RAM for you. In my case, I'm running DDR4 3200 megahertz RAM. I've found that it's actually stable overclocked to 3300, but again, this isn't an indication of what you're going to get out of your system. This is just what I was able to get on mine. So we'll move down to extreme tweaking now. This is a little bit of a funny one. It doesn't really explain exactly what it does, but under some benchmarking conditions, it actually improves the performance slightly to enable this, so we may as well leave it enabled. I haven't seen any difference in stability with disabled versus enabled, so we just leave it. Now TPU, I leave this on keep current settings. This is where you can actually allow the motherboard to overclock itself, and as I mentioned before, I find that when we do that, it introduces crazy high voltages which are just unsafe for the processor. So I always leave that on just keep the current manual settings. Moving down to Sti D Support. Now we can leave this disabled because we're setting a manual override for our VCORE. So if you were to enable this, What it means is that the processor will actually tell the motherboard what voltage it requires, and the motherboard will do its best to match that voltage for a given clock frequency. So leave that disabled. DRAM timing control, so you can see I'm running 16, 18, 38 timings for my particular RAM, but you'll need to set this up to match the RAM that you've purchased. Again, if you're overclocking, you might want to raise your timings a little bit. If you're underclocking, you might be able to actually you might be able to lower your timings a little bit to get slightly better performance. So it's important to understand that RAM timing and RAM frequency combine to actually come up with the final performance. So having a high frequency at higher latency is the same as having a lower frequency at lower latency. So moving down now to external digipower control and internal CPU management. We'll come back to those a little bit later on. And we'll move on down to our CPU core current limit. So we want to set this to the maximum setting, which is 255.5. You can just type in whatever you want here. If I was to type in a bunch of numbers, you can see it jumps back to 25550. What this is doing is it's just overriding the current limit maximums so that we don't get throttling under higher current levels. So set that to maximum. Ring down bin, I like to set that to automatic. And what this does is it allows the motherboard to control the control the core and the motherboard frequency ratio independent of the processor's clock speed or multiplier. So with this one, I usually started around the sort of 42 mark and then work my way up once I know the processor's stable. My end result was 46 here, so that was where I found the stability point was. Any higher than that and I started to get a couple of crazy things going on. B clock aware adaptive voltage, leave that disabled. That is where you would set up things like your adaptive frequency control and stuff like that, but we're going to leave that disabled for now. If we enable it, we can see under our core and CPU cache voltages, we have offset and manual mode enabled. If we were to enable SVID support, so set that enabled, then you'll see we also have a offset mode available as well. Now the adaptive and offset modes again allow us to have different voltages depending on the clock frequency. What I find is that can introduce instability where the system would otherwise be stable. And one important thing to understand here is that voltage isn't what kills CPUs, it's the current that kills them. So as you increase the voltage, you're increasing the capacity for more current to be pulled through the CPU, and that's where degradation and stuff like that can occur. But what I want you to understand is that having a CPU sitting idle at a higher voltage isn't going to do damage to the CPU. It's not until you introduce load that you start to damage your CPU. So my personal opinion on this is that the potential gains versus potential disadvantages of using adaptive or offset modes just isn't worth it. The power savings that you're going to make are absolutely minuscule. There's no additional risk to your CPU sitting at higher voltages under idle conditions anyway. And I just really don't see the point. So I always leave this on manual, leave my adaptive voltage set to disabled, and leave my SVID support set to disabled. That way I have full control over my voltage. So we set our CPU core and cache voltage to manual. Now, this is where things are going to vary depending on your particular setup. So CPU core voltage override, my final value here that I was able to achieve for my particular clock speed was 1.39 volts. Now, if you watch my previous video where I shared the results of delidding, it actually goes into the details of what voltages I was needing for each clock speed to be stable. And of course, we will be doing another video later on explaining how to test stability and stuff like that as well. But what I would suggest here is starting off with a voltage of 1.3 volts, remembering that if we scroll back up again, our CPU ratio to begin with, we're going to be setting 0. And if you've got an 8086, you'll be setting it to 50. If you've got an 8700K, you'll be setting it to 48. So we're setting it at a slightly lower clock speed, which on most chips should be achievable at around the 1.3 volt mark. And 1.3 volts is the point where I'd say it's probably safe for most people. So if you've got a decent quality air cooler, a non-delidded chip, 1.3 volts is probably going to be sort of towards the upper limit of what you're going to want to run before you start to run into thermal overload or thermal cutoff or thermal throttling. And if you're running a decent water cooling setting, you'll be able to go up to maybe 1.35 volts. Once you're delidding, you can get up into that sort of 1.4, 1.425 volt range before you start to get into danger zone. But look, I mean, it's one of those things. It's up to you whether you want to run higher voltages or not. You'll find on most processors, the higher the voltage, the less the gains become over time. So there's a sweet spot for most processors. Once you start to push past that, you're having to push massive voltages to get small overclocks. So I can actually run 5.2 gigahertz with AVX load on my CPU, but it needs a lot of extra voltage to do that. So I found the sweet spot for me was 1.39 volts with a AVX frequency of 5.1 gigahertz, non-AVX 5.2 gigahertz. So set that to 1.3 volts to begin with. DRAM voltage is going to be stipulated by the voltage that your RAM is set to come from factory. So in my case, it's meant to run at 1.35 volts. I've ramped it up to 1.395 so I can get that extra little bit of frequency there. So if you're running 3200 megahertz, 1.35 volts for my particular RAM. But again, check with your RAM manufacturer, check the package that actually came with your RAM. It usually says what voltage you need. So moving on down to the CPU Vcc I voltage. This I've got set to automatic at the moment simply because I'm trying to troubleshoot a cold boot issue that I've got going on, as well as the system agent voltage as well. And I'm wondering whether maybe the low voltages that I had set here were introducing some instability on cold boot. What I would recommend, have these set to auto to begin with while you're establishing stability for your particular settings. And then once you've established that the processor is stable under auto, you can start to lower these voltages. So on the standard processor straight out of the box, these are sort of sitting at the 1.0 to 1.1 voltage range. When you set it to automatic, it does actually push these quite high. So 1.34 volts is definitely on the high side of what I'll be wanting to run for 24/7 use. And also system agent voltage, I wouldn't really want to go much higher than that. But these are safe to begin with, and then what we can do is we can lower those voltages over time. My particular processor is actually stable under stress testing conditions on VCC I at 1.23 volts and system agent at 1.17 volts. But because I'm fine tuning and trying to get rid of this cold boot issue, I've got these set to auto for now. Now the rest of these you can just leave set to automatic. Really not going to get much more performance out of this system unless you've got a specific issue by changing those. So just leave those on automatic. Now we'll move back up again to our power management systems here. So external digi power control, load line calibration. So different motherboards will have different load line calibration settings, and basically what load line calibration is it's the adjustment that the VRMs on the motherboard make to stabilize the VCORE voltage under load. So you can imagine when your CPU goes under load, it suddenly has a massive surge of current. And what happens is the capacitors that are storing current or storing energy on your motherboard get pulled down. So what happens is the voltage drops, and that can introduce instability. So say my system is stable at 1.4 volts. When I put it under load, the voltage drops, and then I introduce instability because the voltage is lower. So setting a load line calibration actually allows the motherboard to compensate for that to an extent by actually upping the voltage so that when it gets pulled down, it actually stabilizes the voltage. So what you'll see is with a level 6 on these motherboards, your CPU core voltage will actually go up a little bit under load. Now, we're going to do another video later on talking about load line calibration because there's a lot of sort of detailed stuff here. But for the purpose of this video, set this to level 6. You might find later on you're able to get away with level 5. What you'll find with level 5 setting is that the VCORE will actually drop a little bit under load. You might find that it's stable anyway. You might find that you need to raise your VCORE just slightly so that under load, when it droops down, it's still stable. But set it to 6 to begin with while you're establishing your stability. You can always adjust it from there. I definitely wouldn't recommend going to level 7 though on these motherboards because that does have quite a bit of voltage overshoot. And we'll talk about overshoot again in more detail later on in another video. So moving down to current capability, set that to the maximum, which is 140%. That way you're not going to be getting current throttling. VRM switching frequency, you might find you're able to leave this set to automatic, but I want to take full advantage of the high quality motherboard that I've got here. So I set this to manual, set my VRM switching frequency to 500, which is the maximum for this motherboard. What that does is it allows the motherboard to adjust for oscillations in current very, very quickly. I set my power duty control to extreme, and I leave my power phase control on standard. If you do have instability, you can set this to extreme, but it does start to introduce more heat into the motherboard. So leave this on standard if you can. Thermal control, leave on automatic. Now DRAM current, set that to the maximum again, which is 130. And all the rest in the settings in here, you can leave on automatic. Jumping down to internal CPU management. Now, I always disable speed step because I want my CPU to be running at its maximum potential all the time. You do also need to set your power profile inside Windows to the maximum performance setting to override this. So even with this disabled, you will find that your CPU frequency will still adjust in Windows if you don't set that to maximum. Turbo mode obviously enabled. Now, these ones as well you want to set to the maximum here. So long duration power limit, you can just type in a high number here and it will default back to the maximum. Power time window I like to leave on automatic because I don't really see this being an issue. I've never seen a scenario where it needs to be adjusted. And short duration package power limit as well, set that to the maximum as well. Again, these are just to stop you from throttling under maximum power loads, assuming that you have good cooling. So that's pretty much it, guys. Under CPU configuration as well, you'll want to scroll down to the very bottom to CPU power management control. Again, set your speed stepping to disabled, and you can also disable your C states here as well, which is what controls the voltage adjustment and the power levels under different frequencies. Because we're not using adaptive frequency and because we're using manual voltages here, we're not going to need that anyway, so we may as well disable it. And that is pretty much it. So what you'll want to do now is go across to your tool here, and you'll see you've got ASUS Overclocking profile. Save your settings to one of the profiles and put in a meaningful name as well. So you'll type in what you want to save it as here. And then you simply want to go back across to exit, save changes, and reset. Now the system will shut down. It'll reboot. It'll probably do what's called memory training. So it'll power up for a couple of seconds with a blank screen, then turn off again. That's perfectly normal. And then it should just boot back up again and boot into Windows. Hopefully it boots into Windows successfully. So if you do have any problems booting into Windows with the settings that we've used here, the first thing I would suggest is lowering your CPU ratio. So go maybe one lower. So if you're setting at 48, go to 47. If you're setting at 50 for an 8086, go to 49. Try again, see if it's stable. If it's still not stable, you can go lower again, or you can start to raise your CPU core voltage. But what I would recommend is always establish stability at the lower voltage first. Keep an eye on those temperatures. Make sure they're within what you deem to be safe for you. Obviously, you don't want to go above about the 90-degree range. For me, I like to sort of stay in the mid to high 70s. Don't like it to go into 80s. But look, in saying that, 80 degrees is perfectly safe. I just like to keep the temperatures as low as possible. So as long as your temperatures are under that sort of 90-degree mark, you're okay. If it starts to push into 90 degrees, you definitely don't want to be going any higher on your CPU core voltage unless you delete your processor. So if it is unstable, I would recommend definitely lowering your multiplier first. If it's still unstable or you want to raise your voltage, you scroll back down to the bottom here, go to your manual core voltage override and raise that by maybe 1 millivolt, something like that. So I might go up to 1.34 in this case and see if it's stable then. If you're still unstable, you might want to try lowering your memory overclock, things like that, to try that out, as well as your CPU core ratio as well. But fingers crossed it'll all boot up for you successfully. I think at the settings that I've said here, most people are going to be fine. I very much doubt whether you're going to have any problems at all because we're being pretty conservative with our overclocks. So once you've got it all up and running and everything is booted up successfully, go into your favorite stability testing software, run some tests, make sure those temperatures are safe, and from here you can start to make some more adjustments. So what I would normally do first is start to lower my VCORE until I reach the point where the system becomes unstable. Then we can start to push higher overclocks as well. So we'll raise our multiplier, which is here, until we reach the point where it's unstable, then raise our voltage up until the point where we're happy, see what our maximum overclock is here, then we can start to do some testing with things like Avx core instruction offsets and our core ratios as well. So look guys, that is the basic information on how to overclock with a Maximus X motherboard using an 8086K or an 8700K processor. I hope you guys have found this video interesting and useful. As I've mentioned, I will be doing more videos where I go over the details of exactly what these settings mean and how to do more fine-tuning. But for an off-the-shelf, straight-out-of-the-box system, hopefully this has been interesting for you. Do stick around and subscribe to the channel. Hit that notification button as well so you don't miss the next one. Got a whole bunch of videos coming about overclocking, PC thermals, how to keep things running cool, and a bunch of other stuff as well. So stick around. Thank you very much for watching, and I will see you in the next video. Bye.